Okay, so inverse functions. If reversing inputs and outputs of a function results in a function, the new function is called the inverse of the original function. A function which has an inverse is called invertible or one-to-one. The following example will illustrate the difference between an inverse function and some other types of inverses. This formula here is a formula for converting Fahrenheit degrees to Celsius. And because there's only one formula for C, Celsius is a function of Fahrenheit. If we solve this formula for F, we get the formula F equal 9/5 C plus 32. There's only one formula for F, so that means that Fahrenheit is also a function of Celsius. So these are the inverse functions of each other. So there's actually several types of inverses involved here. We have the inverse function, the concept of inverse function that's reversing inputs and outputs. So but we also have a multiplicative inverse and an additive inverse. So negative 32 is the additive inverse of positive 32. 5/9 is the multiplicative inverse of the reciprocal of 9/5. So three types of inverses are applied here, but for the inverse, the function inverse kind of incorporates this particular function inverse actually sort of incorporates those other two inverses. So we're also sort of reversing the order of operations. So from Fahrenheit to Celsius, we first subtract 32 and then multiply by 5/9. Celsius to Fahrenheit, we first multiply by 9/5 and then we add 32. So we have a multiplicative inverse, an additive inverse, and we're reversing the order of operations, and the overall effect here is a function inverse. Okay, so another example, the inverse function of 1 comma 4, 2 comma 5, 3 comma 6. So we're just reversing the inputs and outputs. So the inverse, the answer is going to be, instead of 1 comma 4, we're going to have 4 comma 1. Instead of 2 comma 5, we'll have 5 comma 2. And instead of 3 6, we have 6 3. Okay? And the domain of the original function is the range of the inverse, and vice versa. So the domain of this new function is 4 5 6. 4 5 6. And that was actually the range of the original function. Inverse function of f of x equal x squared. There's a procedure we can go through. This function actually, the inverse is not a function, but we'll go through the procedure anyway. The first step is, instead of f of x equal, we want to write y equals. And then step 2, switch to x and y and solve for y. So we'll have x equal y squared. Usually it's traditional to put whatever you're solving for on the left, so we write this y squared equals x. And then we want to get rid of the exponent, so we can do that by taking the square root. And most numbers have 2 square roots, so when you take the square root, actually you want to do plus or minus to get both square roots. And because there's 2 formulas for y here, the inverse is actually not a function. So the inverse is not a function because there's two formulas, not a function, because there's 2 formulas for y. Okay, but we can follow the same procedure, and maybe we'll get an inverse, maybe we won't. Find the inverse of f of x equal 1 over x minus 3. Step 1, instead of f of x equal, write y equals, then step 2, you want to switch x and y and solve for y. Okay. So we'll have x equal 1 over y minus 3. We want to get the y out of the denominator, so we can multiply both sides of the equation by the quantity y minus 3 to get that out of the denominator, and those will cancel, and we can distribute the x here, and that will give us xy minus 3x equals 1. And then we want to isolate the y, so we want to add 3x to both sides of the equal sign. That'll give us xy equals 3x plus 1. And then divide everything by x. And the x's will cancel on the left. And that'll give us y is equal to 3x plus 1 over x. And then step 3, instead of y equal, we'll write f inverse of x equals. And x cannot be 0. So the domain would be all numbers except for 0. So this looks, this notation looks like a multiplicative inverse. So besides the terminology, there's also the notation that it makes it easy to confuse one type of inverse for another. But this notation in a different context is also used for a multiplicative inverse. But in this context here, it means the function inverse, which may or may not include a multiplicative inverse. But anyway, this is the function inverse. One of the properties of inverse functions is that if you compose a function with its inverse, you get x. So let's see what happens if we compose for this function here. If we compose it with its inverse, so f of f inverse of x. So in the formula for f of x, instead of x minus 3, we're going to write f inverse of x minus 3. So this is going to be 1 over f inverse of x minus 3. And then f inverse of x, we said, was 3x plus 1 over x. So we can make that substitution. 1 over 3x plus 1 over x minus 3. And then we have a fraction within a fraction. And so we want to multiply each term by the denominator of the inside fraction. So we'll have 1x over 3x plus 1 over x times x minus 3x. So the x's will cancel here. 1 times x is just x. So this is going to be x over 3x plus 1 minus 3x. Well, 3x minus 3x is 0. So we'll just have x over 1, which is equal to x. Okay, so that's as it should be. That's kind of like a check to make sure we did the inverse correctly. When you compose f with f inverse, you should get back just x, the identity function. And the same with if we do f inverse of f of x. We should get the identity here. So in the formula for f inverse, instead of 3 times x, we want to write 3f of x. Instead of dividing by x, we divide by f of x. So this is going to be 3 f of x plus 1 over f of x. And then we put in the formula for f of x, which was 1 over x minus 3. So 3 times 1 over x minus 3 plus 1 over 1 over x minus 3. Okay, so we have, again, fraction within fraction. We can multiply each term by the denominator of the inside fraction. Well, 3 times 1 is 3, so it's 3 over x minus 3, and then multiply by x minus 3 over 1 over x minus 3 times x minus 3. Okay, so the x minus 3's will cancel here and here. We can distribute the 1, and this will give us 3 plus x minus 3 over 1. 3 minus 3 will cancel, and that gives us x over 1, which is equal to x. And that's what we would expect. If we did everything correctly, it should equal f inverse composed with f should equal x. You can also get the inverse from the graph. This one we see that this one the inverse is not going to be a function because it fails the horizontal line test. So now there's certain places where if you draw a horizontal line, it'll hit the curve in more than one spot. So inverse is not a function. We can tell from the graph it's not a one-to-one function. Inverse is not a function. It fails the horizontal line test. So we have the vertical line test to see if it's a function, and we have the horizontal line test to see if the inverse is a function. It is a function because any vertical line will only touch one spot, but the inverse is not a function. Here's another example of using the graph to get the inverse. And this one is one-to-one. Any horizontal line only touches in one spot. Any vertical line only touches in one spot. So this is a one-to-one function. And the way we can get the inverse is to reflect it across a dotted line. So I'll make a dotted line here. There's a dotted line where y is equal to x. This dotted line here is the line where y equals x, and we want to reflect it across that line. So so this point here, if we go straight across the line, we get a point here, right? Let's say this point up here, this is up 3 on the y-axis, so it'll be across 3 on the x-axis. Actually, it's not quite at 3, so and then it's up 1, so it's about right here probably. This point here, 1, 2, 3, 2, 3, about right here. So something like this. It's a reflection of across the x-axis, and that concludes this presentation.